So let's see the other possibility. So what is possible that in the type 1 of improper integral, it may be possible that both the limits are infinite, like you have the integral from minus infinity to infinity for the function fx dx, and it is given that the function is continuous in this interval. Then what you have to do is select c as any real number and break this into two parts, minus infinity to c and plus c to infinity. So what will happen here is your entire integral was from minus infinity to infinity. So you have selected a point c and divided this integral into two parts. So integral minus infinity to infinity become integral minus infinity to c and then integral c to infinity. So finding the integral over the interval minus infinity to infinity is same as finding the integral from minus infinity to c plus c to infinity. And this minus infinity to c and c to infinity can be solved in the ways of 1 and 2 that we had discussed in the previous video. Okay, it's not necessary that always the value of this integral will exist. If the value exists, we say that the limit of the integral exists and the integral converges. Suppose the value is infinite, in that case we say the integral diverges. Okay, let's see it with the help of example. So let's solve this question. Here, question number 3, you see that both the limits, upper limit and lower limit, both are infinite. So in this case, we have to break this into two parts. So what we will do? We can write the integral minus infinity to infinity dx over x square plus 9 as integral minus infinity to c dx over x square plus 9 plus integral c to infinity dx over x square plus 9. Now what happened? We will solve this part 1 and part 2 separately. Okay, so let's write down the part 1. So part 1 is integral minus infinity to c dx over x square plus 9. So what we can see here, the lower limit is infinite. So what we will do in this case, we'll use limit. Let's say limit a goes to minus infinity. Integral a to c dx over x power 2 plus 9. Can I write 9 as 3 power 2? Yes. So now using the rule of this integration. So what's the rule? Rule says that this is limit a goes to minus infinity 1 over 3 tan inverse of x over 3. Okay, and x goes from a to c. Substituting the limit, we get this is x. So one time substitute x is equal to c and other time replace it by a. So this gives you limit a goes to minus infinity 1 over 3 tan inverse of c over 3 minus tan inverse of a over 3. Okay, and when we substitute, like we replace a goes to minus infinity, this term become tan inverse of infinity. We know that its value is pi by 2. So the value of this integral is, yes, the first term will remain unchanged because c is not getting affected. So it is 1 over 3 tan inverse of c over 3 minus pi by. Okay, so this is the value of first integral. In the same way, we evaluate the second integral. Second integral, which is from c to infinity dx over x square plus 9. Again, rewriting it as limit b goes to infinity. Note that we have to use different variable. Here we have used a, but a is going to minus infinity. So here we have to use b, which is approaching to infinity. Okay, c to b dx over x squared plus 9. And doing in the same way, we can use the same rule here. This is limit b approaches to infinity. We get 1 over 3 tan inverse of x over 3. Limits are from c to b. So when we substitute the limits, we get here limit b goes to infinity 1 over 3 tan inverse of x is b over 3 minus 1 over 3 tan inverse of c over 3. Okay. Again, when we substitute, means when we replace b by infinity, what happened? This term will become tan inverse of infinity, which is pi by 2. So, giving us the value as 1 over 3 pi by 2 minus tan inverse of c over 3. Okay, so this is the answer for 2. So, the final answer for this question will be, yes, what it will be? Yes, for first, what we have 1 by 3 tan inverse of c over infinity. So if we write the answer, let's write it over here. So this is the answer for part 1. That is 1 over 3 tan inverse of c over 3 minus pi by 2. Let's write it here. 1 over 3 tan inverse of c over 3 minus pi by 2 plus for the second part, answer will be 1 over 3 pi by 2 minus tan inverse of c over 3. 1 over 3 pi by 2 minus tan inverse of c over 3. So what this gives you? This is 1 over 3 tan inverse of c over 3 minus, we are multiplying 1 over 3 with both the terms. Okay. So we get minus pi over 6 plus pi over 6, and what we get here minus 1 over 3 tan inverse of c over 3. So what you can see here, 1 over 3 tan inverse of c over 3 cancels with this, pi by 6 cancels with this. So we get the value as 0. So we can say that integral minus infinity to infinity dx over x squared plus 9 is 0.